All right, number 21, we start with the original equation unchanged. Notice that I'm saying that a lot. I hope that that sinks in. It's an absolute requirement. In fact, there's no guessing about it. There's nothing difficult about it. Okay, there's the original equation unchanged. What's happening to x? Well, it's being multiplied by -5, and then also 2 is being subtracted from it. And how do we undo that? Well, we undo what order of operations would say is done last if you knew what x was. If you had a value for x, you would first multiply by -5, then you would subtract 2. So we have to undo that -2, which is the last thing, with its inverse operation of +2. So we take everything that was originally there, -5x minus 2, and we write it, and then we say +2. Take everything that was originally there, 13, say +2. Now in this step, you are simplifying. So the -2 and the +2 cancel out, leaving you with just -5x, and the 13 plus the 2 is 15. Okay, and we look at x and see what the coefficient of it is. It's -5. That means x is being multiplied by -5, and we undo that with the inverse operation of divided by 5. So we're going to write it on a new line and do that divided by 5. Okay, this line is simply to demonstrate what the result of this was when simplified. Now you have that. On a new line, you have the division. So here you would say, if we were naming what we're doing, we're saying original equation, addition property of equality, or add 2 to both sides, simplify, and now on a new line, you say division property of equality, or divide both sides by -5. Okay, this simplify from here to here is its own line. Okay, and what do we get? Let's see. -5 divided by -5 is 1, so we have 1x, or just x, and 15 divided by -5 is -3. Box your answer. For your proof, you write proof, and then you write the original equation unchanged, -5x minus 2 equals 13. We are now rewriting the exact same thing, everything exactly the same as it was before, but wherever there was a variable, you put parentheses and sub in the value. Once you start to learn this, it's kind of satisfying to say, I know what these first 2 steps look like. There's no way that I'm going to get wrong the first 2 steps of my proof, because I write the original equation unchanged, and then I rewrite it exactly the same way and put parentheses wherever there was variables and put the number in. Any other errors that you might make, those first 2 steps should be clear and easy, and it should be satisfying, because you're like, all right, I'm already 2 steps away from mastering this 2 steps in to mastering this process, right? I've already got the first 2 steps guaranteed. So let's keep going. We need to now simplify the left-hand side and the right-hand side separately. On the left-hand side is the expression -5 times -3, and then -2. So what do we simplify first? Order of operations says do the multiplication. You do -5 times -3. And what is that? Negative times negative is positive. 5 times 3 is 15. So you get 15. Still have the divided by, subtract 2 rather. So 15 minus 2. And the 13, there's no way to simplify 13. It's as simple as it's going to be. So that just keeps moving down the page. Okay. Now 15 minus 2, we can do that. 15 minus 2 is 13. So we get then 13 equals 13, and we give it a check mark because it worked out the way we needed it to as a proper proof. We are simplifying this algebraic expression once we substituted it in using order of operations and simplifying it down until a single number without regard to what this is. We just ignore what's on the right hand side, and that is done separately. And when we finally get a number here, that's when we look and see if it matches. I mean, I know you can see it, but you shouldn't let that influence what you're doing over here. The math that you're doing over here is independent of what happens on this side. Okay, you do the calculations, you write the number, you do the next calculations, you write the number, and only at the end when you've got a number on each side, you check and see whether they're the same, and they are. So this is a proper solution and a proper proof.